which is the blueprints for some kind of a machine, and breaking down into very tiny modules of all the different steps that are required to make it happen. Now for hardware, that's quite difficult, much bigger problem than software, because anybody that builds a machine, I mean, they're using it pretty much. The compiler is different. I mean, the compiler in the hardware really is, it's not a piece of code that you run to compile a piece of software. The analogy goes that the compiler is the machines, and it's the people, it's the materials that you use to build that. Most people will adapt their own materials, they might modify the plans a little bit for their own needs, or just use different tools, and that'll could potentially make minor variations in the resulting product. So literally every new build is like a fork, and we have to document all of that. So anytime we go to a new version, we pretty much set up these development spreadsheets for that whole machine and start over. Pretty much take all the relevant stuff from before, then keep building on that. But the documentation game, it's really hard. It takes a lot of effort. It's a major challenge, and we're trying to streamline how to do that. Another great example of modularity by design is there's the WikiSpeed open source car project, and that is where they're breaking down the whole machine into a frame, wheel units, interior frame, body, and then people are developing those in parallel. So these guys have been able to design a car that's a 100-mile-per-gallon car in rapid time using these kinds of techniques. So it's just a good picture of how that works in practice. More than the modular design pattern, we also treat our work as construction sets. That's within our very name, the Global Village Construction Set, but everything that we take on is like a construction set in itself.